This is our last topic of this unit, and I'm going to try to go through it pretty quickly here. Some of it you probably already know, you've been exposed to, so we're going to discuss the idea that as materials gain or lose energy, they can change and become what we call different phases or different states of matter. Typically what we see is things exist as solids, liquids, or gases. There is a fourth state of matter called plasma, which we don't really worry about at this point. And one thing to probably keep in mind with all this is the substance that you've been familiar with most of your life that does this, which is H2O. So we know that by adding heat or removing heat from H2O, we can change it from one of these things to another, and we've got vocabulary words that you've used all of your life for most of these examples that we have here. So the thing to keep in mind with this, as something's going from a solid to a liquid to a gas, it has to do with energy. Either we're adding energy or we're removing energy. And let's try to remember, when we're adding energy, if we're giving additional energy to this, usually that means that we're adding kinetic energy. But not always. We'll talk a little bit more about this in a minute. But imagine if you're adding more kinetic energy has to do with movement. So if we're looking at things on the tiny particle level even, so we're talking like H2O molecules, and let's say we had a cube of ice or some water, just a little bit, there'd be, gosh, I don't know, millions, billions, trillions of individual molecules, each that has its own amount of kinetic energy. If it's a solid, they're going to have very little kinetic energy. If it's a gas, they're going to have a lot. Again, because think about why. It has to do with the amount of energy that's there. So as we add kinetic energy, we're going to add movement to these. Okay, so we expect solids to have little movement. We would expect gases to have lots, and then this would correspond to the amount of energy as well. So there would be little energy, whereas here we would expect there to be lots of energy. Therefore, for us to get something to go from a solid to a liquid or a liquid to a gas, we need to be able to add energy. And if we go in the opposite direction, if we take a gas to a liquid or a liquid to a solid, we're going to have to go in the opposite direction. We're going to have to remove the energy. Right. So that is one of the main ideas that we're going to have on here. Apologies for the brief delay. I couldn't find my control panel at the bottom of the screen. So one of the other concepts we need to keep in mind here is, let's think about temperature. Because as we turn something from a solid to a liquid or liquid to a gas, we expect the temperature to go up. But what temperature actually is, it's a measure of the average amount of kinetic energy. So let's think about that. So that means if the temperature is increasing, so an increase in temperature equals an increase in kinetic energy. If there's a decrease, then we would expect a decrease. And if the temperature isn't changing, then that means that the average kinetic energy is not changing. And by average, we mean if we looked at all the individual molecules in a sample, if the temperature is going up, then the average amount of movement in that sample is going up. And likewise, if the temperature is going down, the average amount of movement of all those molecules is going down. So we would just kind of add up all the energy and divide it by how many molecules we've got, and that would give us the amount of kinetic energy that we've got right there. Okay, so let's just kind of keep that in mind as we look at some graphs here in a moment, because as we are adding energy, sometimes the temperature goes up and sometimes it doesn't. So let's try to keep that in mind, because if the temperature does go up, that means the molecules in there are moving around more. If the temperature doesn't go up, then the movement is not going up. The kinetic energy is actually not going up with that. And let's also remember what total energy is. Total energy is kinetic plus potential. So imagine that we are heating something up. If we're heating something up, we should be adding energy. And usually if we're adding energy, we're going to be an increase in temperature. If we're adding energy and the temperature goes up, that means that there's going to be an increase in kinetic energy. But there's sometimes where we add energy and the temperature actually doesn't change, and this occurs when something is melting or when something is boiling. So think about this. If we're adding energy and the temperature is not going up, then what's going on? So if we're adding heat, but there's no temperature change. Well, we're adding more energy, we're adding more total energy, and so if there's no temperature change, that means that the kinetic energy must not be going up. So there's times when we actually add heat and what's happening is actually there's an increase in the potential energy of what's going on, because potential energy doesn't affect temperature. The only thing that affects temperature is kinetic energy. Kinetic energy has to do with temperature. So if we see an increase in temperature, that means we're going to get an increase of kinetic energy. If we add heat and there's not an increase of temperature, then there can't be an increase of kinetic energy. Therefore, if we add heat without a temperature change, what must be happening is we're adding additional, it's storing up the energy before it gets all the way through a phase change. Okay, so that's one concept. It might not really be assessed, but it's an idea that we want to look at here in a minute. All right, so as we add heat or add energy to a substance, two things can happen. So one thing is the temperature goes up. All right, so if we have a glass of water, we add some heat to it and put a thermometer in, the temperature goes up. So that's one obvious thing that can happen if we add energy. The second thing that can happen is we get a phase change. And again, a phase change is when we get a solid changing to a liquid or a liquid to a gas and so forth. So these are our two choices. You can't have both happen at the same time. Either one is happening or the other one is happening. Okay, so that means that when the temperature is going up, there's not a phase change, and during a phase change, the temperature can't go up. We've got some vocabulary words that go along with all this, because we've got solids, we've got liquids, and we've got gases. So if we take a solid and turn it into a liquid, I think y'all know this, that's melting. If we take a liquid and we turn it into a gas, usually that's boiling, but that is also called evaporation. And if a gas turns back into a solid, this doesn't happen very often. I can't even really give you some examples of when that would occur. Is called deposition, and that's probably not a vocabulary term that we really need to worry about too much. All right, we can go in the opposite direction as well. If we get a liquid turning into a solid, you know that the opposite of melting is freezing. If we get a gas and turn it into a liquid, the opposite of evaporate is to condense. Condensation. This happens like if a gas cools off. You see this on your windows in the morning right now, or at least the last several weeks. Usually in the morning, the inside of your house is cool, the outside of the house there's a lot of humidity, and so the moisture in the air gets cold, and you get moisture on the outside of the windows at your house, and it has to do with the temperature of the glass that's on there. So the air that's touching the glass on the outside, because it suddenly gets a lot colder, turns from a gas into a liquid. And a solid can turn into a gas. This happens every once in a while. This term, I'll write it over here because it's a little bigger, is called sublimation. This is like dry ice, which is it's not H2O ice. I believe it's carbon dioxide, but usually it's a solid, which is why we call it ice. But when it warms up, it doesn't turn into a liquid. It kind of skips over the liquid part and goes all the way to a gas. So those are our 6 vocabulary terms about what turns into what. We probably want to make sure that we at least have a clue of those to be able to identify them. And what do they have in common? Well, these are all phase changes. And so if they're all phase changes, that means that we're either adding or removing energy for that to occur. And while these processes are happening, there is not a temperature change occurring. Okay, and so we'll go over that here in just a second as well.